All right, so today we're really going to be talking about quadratic inequalities and solving quadratic inequalities. But first things first, we're going to do an inequality that has an absolute value in it. Okay, so here I have 2x minus 3 is less than 5. Okay, the absolute value of 2x minus 3. In this case, yes, we know that we have to be less than 5, but we can't be less than negative 5, right? If we were to get the absolute value of negative 6, well, 6 is not less than 5. So we also need to be greater than a negative 5. Okay, so when we have this absolute value of 2x minus 3 is less than 5, well, this is really a two-sided inequality. Because yes, we have to be less than 5, but we have to be greater than negative 5. Okay, so when it's a less than sign, we have to be between the negative of that number and the positive of that number. Okay, and now we can just get rid of the absolute value. Okay, so 2x minus 3 is less than 5 and greater than negative 5. Add 3 to each side. Negative 2 is less than 2x is less than 8. 8, there it is. Okay, divided by 2, negative 1 is less than x is less than 4. Okay, so we know that our x needs to fall in this range. Let's check just to make sure it works. Okay, I'm just going to put it negative 1, 4. I'm going to check a number in between. So let's check 0. 0 minus 3 gives me a negative 3. Absolute value of negative 3 is 3, so that works. Let's check a number greater than 4. We'll try 5. 2 times 5 is 10, minus 3 is 7. Absolute value of that is 7, which is not less than 5. And then we'll try negative 2. Negative 2 times 2 is negative 4, minus 7 is negative 7, and absolute value of that is 7. Okay, so this tells me, yep, this is definitely correct. Okay, and if I'm putting that in interval notation, it's going to be from negative 1 to 4. And those are my correct answers. All right, so when it's less than, if it's an absolute value and it's less than a number, we know that we need to be between that number and its negative. Okay, let's do another example, and I'm going to use the same exact numbers here. Okay, but I'm just going to change this sign. Okay, and I'm going to erase all of this. So now, instead of having 2x, the absolute value of 2x minus 3, oh, are you kidding? Sorry, one more try. Here we go. Come on, eraser. So instead of having the absolute value of 2x minus 3 is less than 5, I'm going to do the absolute value of 2x minus 3 is greater than 5. Okay, and let's think about how that's going to change. So the absolute value of 2x minus 3 is greater than 5. So now we know that that means 2x minus 3 has to be greater than 5, or 2x minus 3 has to be less than negative 5. Okay, so now I'm going to solve both of these. So add the 3 over, 2x is less than a negative 2. X is less than a negative 1. Or now I'm going to solve this other one. Here, let me divide it up. Okay, add the 3 over, 2x is greater than 8. X is greater than 4. Okay, so now I have x is less than negative 1. Okay, x is less than negative 1, and x is greater than 4. Okay, but if we put those on a number line, obviously we can't be both, right? Negative 1 and 4, right? So that's saying x is less than negative 1. This here is saying x is greater than 4. So in this case, I could be either less than negative 1 or greater than 4. Both of those are going to satisfy. And again, you can always plug in numbers to check. Let's try 0. 0 minus 3, negative 3. Absolute value of that, obviously not greater than 5. Okay, if you try 5, that should work. And if you try negative 2, that should work. Negative 2, that's going to give us 7, right? Negative 4 minus 3 is negative 7, absolute value. And then 2 times 5 is 10, minus 3 is 7. Okay, so those both work. Now, writing this in interval notation, this is where things can get a little tricky. I'm always going to start with my most negative one. Okay, so I'm going to start just like you read a book, go from left to right. Okay, so starting all the way to the left, this interval here, x is less than -1, is going to be negative infinity. Why is it doing that? Negative infinity to -1. Okay, and then I'm going to use this u. This u here means union. It really means or. Okay, so it's whenever you have two intervals and you want to combine them into one. So I had x is less than -1 and x is greater than 4. Well, I'm going to say it could be this or that. So you use the union. Okay, and that's just a u between them. So this one here is saying x is less than -1. This one here is saying x is greater than 4. And I could be either, so I'm going to use my union. Okay, and this is your final answer. All right, so looking at the top here, what do we notice? Well, when we had a less than sign, right, we solved this, and it could be either -1 or 4, right, if this was an equal sign. Okay, and we find that our interval falls between the two numbers. Okay, so when we have a less than, my interval is going to fall between the two numbers here. Okay, when I have a greater than sign, my interval falls on the outside of the two numbers. Okay, so taking that, we're going to do the same exact thing with our quadratics. Okay, so whenever you're solving a quadratic inequality, the first thing we're going to do is just solve this for when does it equal 0. So x squared minus x minus 12 equals 0. We have a quadratic. We could do completing the square. We could do the quadratic formula. In this case, it's a pretty easy factor. What multiplies to -12 adds to -1. That's going to be -4 and 3. So x minus 4, x plus 3 equals 0. So x is equal to 4 and -3. Now what I could do is, well, let's put it on a number line. Okay, number line. It's not going to let me draw that side. That's all right. Okay, here's -3, and here's 4. Okay, and so now looking here, well, I had a greater than sign. So I'm just going to guess here and say, well, greater than means that we're going to be on the outside of these two. So I'm going to be on the outside of the intervals. So either greater than 4 or less than -3. Let's just plug in numbers, check to make sure it works. I'm going to put those numbers in a light blue. So if I plug in -4, that should work. If I plug in 5, that should work. Okay, and then in a dark blue, if I plug in 0, right, 0 hopefully doesn't work. So let's start with 0. That's the easiest one to plug in. 0 minus 0 minus 12, well, -12 is not greater than 0. So that doesn't work. Okay, plug in 5. 25 minus 5 gives me 20. Minus 12 gives me 8. So yep, that works. And then -4 squared is 16. Minus a -4 gives me 20. Minus 12 is also 8. So that works. All right, so whenever it's greater than, we are on the outsides. And just writing my answer in interval notation. Okay, remember we start to the left and then go to the right. So all the way to the left is -infinity to -3. Or, so, don't want to use that. Or 4 to infinity. Okay, it could be this interval here or this interval there. Okay, and so that's why we're using this union sign down here. All right, and I'm just going to show one more example, and this example is going to be with a less than sign. All right, so here my problem is 2x squared plus 3x is less than or equal to 20. All right, so there we go. I'm just trying to underline it. So first thing we're going to do, get it all on one side, set it equal to 0, and solve. So 2x squared plus 3x, I'm just subtracting the 20 over, is less than or equal to 0. All right, cool. So now I want to factor this. Let's multiply 2 times -20 is -40. So what multiplies to -40 adds to 3? That's going to be 8 and -5. So 2x squared plus 8x minus 5x minus 20 is equal to 0. Sorry, there should be an equal sign right here. I'm trying to solve right now. Okay, now I factor out a 2x. I'm left with x plus 4. And then I can factor out a -5. I'm left with x plus 4. Okay, so this is 2x 2x minus 5 times x plus 4 equals 0. And so then I should get x equals negative 4 and x equals a positive 5 halves. All right, so let's do the same thing we did last time. Throw it on a number line. Negative 4 and 5 halves, or 2.5, either one. I'll put 2.5. Okay, and so it's a less than or equal to. So I'm going to guess that my interval falls in between. That's where my answer should be. Let's just double check, make sure that's true. So I'm going to check 0, I'll check 3, and I'll check negative 5. Okay, some of these numbers might be a little difficult. And we'll plug this all the way back into my original equation, okay? All the way up here. So plug in 0. 0 plus 0, is that less than or equal to 20? Yeah, good there. Okay, 0 works. 3, I plug that in. 3 squared is 9, times 2 is 18, plus 3 times 3, which is 9. So 18 plus 9 is 27. That doesn't work. And then finally, negative 5. Plug that in. Negative 5 squared is 25, times 2 is 50. And then minus 15 will give me 35. 35 is not less than 20, so that doesn't work. Okay, so we do have the right interval, and putting that in interval notation, it's going to be negative 4 to 2.5 with brackets because it is a less than or equal to. And that's quadratic inequalities.